Welcome to another video in the series of Understanding Injection Molding. In this video, we're going to be covering common plastic injection molding defects and their solutions. At the end of the day, defects equals rejects. When it comes to injection molding, there are a multitude of reasons parts can be rejected due to parts having defects. Some of the more common defects will be covered in this video, along with the key preventative measures. Let's start with sink marks. You can see an image on the right hand side here depicting what a sink mark looks like. So a sink mark is a depression on the surface of the molded part and is generally found where there are bosses or ribs on the underside of the molding. These intersections result in a thicker material section and the cooling is uneven in these areas. As the material cools, the outer surface cools faster than the inner, and with the outer surface solidified, the inner molten material begins to cool, solidifying and shrinking, thus pulling on the already solidified surface. This irregular cooling and shrinking of the material around the thicker areas is the cause of most sink marks. Let's have a look at the key preventative measures to eliminate or avoid sink marks. Ensure wall thicknesses are uniform wherever possible. Make ribs 50% to 80% of the wall thickness it is connected to. Select the thickest section of the part to add the injection gate. This allows the thickest parts to be injected first. Do not have the gate size too small, as this will prevent the optimum fill and packing of the mold. Avoid large thick areas in the design. Better to have a ribbed or honeycomb design if you are looking for strength and rigidity. Increase the injection pressure during the process. This will force more material into the mold and reduce the shrinkage. Reduce the injection temperature of the material and the mold. Voids. You can see an example on the right hand side here of what a void is. So what causes a void? Voids or air pockets tend to occur in thicker sections of a molded part. This is caused when the surface cools and solidifies faster than the inner material. As the inner material is cooling, it also shrinks. But if it is unable to fully shrink, the material molecules will be pulled apart, thus creating voids. Some key preventative measures to avoid voids. Ensure there are no unnecessary thick sections in the part design. Increase the gate size to ensure optimum mold fill. Increase shop volume. Increase injection pressure. Increase screw forward time. Reduce melt temperature or adjust injection speed. Ensure material is dried correctly. Moisture in the material will cause voids. Weld lines. An example on the right hand side here shows what a weld line looks like. Weld lines are created when two melt fronts come together but do not bond with each other because they have partially solidified. When the part is fully solidified, the weld lines often look like two plastic planes have come together. The key preventative measures to avoid weld lines. Have a design where the flow is continuous and not split will prevent weld lines. If a split in molten plastic is unavoidable, ensure the position of the gate allows the melt fronts to come together evenly at the same time. Raising the temperature of the mold or molten plastic will help when the two melt fronts come together. Increase the injection speed will help the melt fronts come together quicker while still molten. Let's have a look at the problem with short shots. Again, we can see exactly what a short shot looks like on the right here. Now, short shots occur because the mold is not completely full before the plastic solidifies, resulting in partially molded part. Another reason the short shots is trapped air or gas in the mold cavity. The molten plastic cannot occupy the same space as the gas, therefore resulting in a short shot mold. Some key preventative measures to avoid short shots. Ensure the gate size is large enough to fill the mold cavity. Ensure the tool has adequate gas or air vents to allow the gas buildup to escape the cavity. Increase the temperature of the mold and plastic being injected. This will help fill the mold faster. Make sure there is enough material being injected into the mold per shot. Increase the injection pressure. Another common problem is burn marks. We can see a typical burn mark here. Now, burn marks show up on the finished part as charred or dark discoloration, which is caused by trapped gas overheating in the mold. It can also be an effect of plastic degradation due to excessive heat or by the injection speed being too fast. Some key preventative measures to avoid the burn marks. Ensure the tool has adequate gas and air vents to allow the gas buildup to escape the cavity. Reduce the injection speed. Reduce the injection pressure. Reduce the temperature of the plastic during injection. And make sure the part design does not have any feather edges, as this can increase the chance of burn marks. A very common problem on plastic molded parts is flash. Now, flash is a defect where the molten plastic has escaped the cavity, generally at the parting lines or vent areas or the even down injector pins. Here are some key preventative measures to avoid flash. Ensure the clamping pressure is being maintained during the injection process. Increase clamp pressure. This could mean changing machines to a larger clamp force capability. Ensure the surface of the mold is clean and not damaged before it is loaded into the machine. Reduce the injection pressure. Reduce the temperature of the mold and the plastic being injected. Check the diameter of the ejector pins and the pin hole tolerances. If the tolerance is too wide, this could allow the molten plastic to flow down between the pin and the hole surface. Make sure the venting is not too large. Flow lines. We can see typical flow lines here. Flow lines are streaks in the surface of the finished part, can be caused for reject if the part is required for aesthetics. Flow lines are caused by the molten plastic flowing at different speeds throughout the cavity and the change in direction of the melt front due to the design of the mold. These lines occur as the plastic starts to solidify at different speeds. In some cases, the molecules are dragged along the surface of the mold, causing streaks. Key preventative measures to avoid flow lines. Ensure that the design of the tool has rounded edges where possible. Increase the speed of the pressure of the injection process. Increase the temperature of the mold and the molten plastic during the injection process. Increase the size of the gate to allow optimum mold filling. Warping is another common problem. Warping occurs when the part cools unevenly and creates internal tension within the part. When the part is ejected from the tool, the part will warp as the internal tension is released. Some key preventative measures to avoid warp in a product. Ensure the cooling time is controlled to allow the plastic to solidify evenly. The variables requiring control would be cooling time and the cooling temperature rate. Reduce the temperature of the material during the injection and the temperature of the mold. Make sure the gate position allows the cavity to fill evenly as possible. If the cavity is filled in all extreme points the same, the solidification process is more even, which helps eliminate warping of the parts. Select plastic materials that are less likely to shrink and deform. Semi-crystalline materials such as PPA, PEK, and high-temperature nylon are generally more prone to warping. Parts sticking in the mold. When the mold part sticks in the mold, it fails to separate from the cavity or is held by a feature of the tool design, which can occur for many reasons. Key preventative measure to eliminate tool sticking is ensure the ejector pins are not broken. Without ejector pins, the part cannot be pushed out of the mold. If the draft angle is too shallow, there will be too much surface friction between the cavity surface and the part preventing it from being ejected. In this case, draft angle needs to be increased. Surface finish is too rough, causing too much surface friction between the cavity surface and the part, preventing it from being ejected. Two things to change in this instance: smooth and polish the surface of the cavity if the smooth surface is permissible in the design. If not, the draft angle needs to be increased to allow for the rough surface to be separated between the part and the cavity surface. Ensure there are no undercuts in the design. These would prevent the part from being ejected, as the part would hang on the undercut surface. Make sure there are no defects or scratches on the cavity surface, as these could act as undercuts and hold the part during ejection. Ensure a release agent is applied to both parts of the tool between each injection cycle. So don't forget to check out our other videos in this series, and you can always contact us if you need any help with your projects at all in China. For your convenience, there's a link just below. Oh, and don't forget to like and share this video. Also, leave a comment with your thoughts. Don't forget to subscribe to our channel if you haven't done already, and hit the little bell symbol, because that will notify you of all new content that we upload. So thanks for listening. My name is Paul Adams from Sofeast, and I shall see you in the next video.